Google's July 2026 launch arrived as a trio of specialized models: Gemini 3.6 Flash, 3.5 Flash-Lite, and the security-focused 3.5 Flash Cyber. This release signals that Google has moved away from the one-size-fits-all model strategy. They are now prioritizing an industrialized ecosystem where different models handle different segments of a workflow. For developers, engineering success now depends on the orchestration layer. You have to decide exactly where to route a prompt based on the specific cost and reasoning requirements of that individual task. Sending high-volume data extraction to the premium 3.6 model inflates your per-task cost, while forcing complex reasoning onto the light tier leads to execution errors and increased latency. Gemini 3.5 Pro remains delayed in partner testing, leaving a vacuum at the top of the performance stack for the time being. In its absence, Google is positioning the Flash architecture to manage the heavy lifting for enterprise agents and complex production loops. This creates a choice in development strategy. You can wait for a single flagship model to eventually handle your hardest problems, or you can build agentic loops today using the optimized tools that are actually available. Building with the current Flash lineup allows you to ship workflows now rather than stalling your deployment until a single model solution passes partner testing. Gemini 3.6 Flash is the general-purpose workhorse of the group, built to handle multi-step reasoning, handles code generation, and multimodal analysis. The unit economics sit at $1.50 per 1 million input tokens and $7.50 per 1 million output tokens. 3.6 Flash requires 17% fewer output tokens than the previous version per task. In software engineering on DeepSuite, output tokens dropped by 65% due to fewer tool calling errors. Against GPT 5.6 Luna and Claude Sonnet 5, it maintains competitive coding and knowledge scores. While the model is intelligent, using it for high-volume tasks like basic classification or simple search is an inefficient use of the API budget. 3.6 Flash is most effective when applied to deep reasoning tasks, where the cost is justified by the requirement for higher logic and precision. For high-volume pipelines, you move to Gemini 3.3 Flash-Lite. This model is built for raw throughput and low-latency response times. The pricing is significantly lower, at 30 cents per 1 million input tokens and $2.50 per 1 million output tokens. Flash-Lite reaches speeds of 350 output tokens per second, particularly when using the minimal thinking configuration for straightforward tasks. Flash-Lite surprisingly scores higher than the older Gemini 3 Flash on coding benchmarks like SWeb Bench Pro and OS World Verified. This makes it ideal for bulk document processing, receipt translation, and structured data extraction needing fast, consistent JSON returns. Warning tone. However, if you deploy it for long horizon logic or deep deduction, the model's accuracy drops, leading to logical inconsistencies in your pipeline. Flash-Lite acts as a guard for the API budget, provided it is kept within its technical limits and away from high-complexity edge cases. The final model, Gemini 3.5 Flash Cyber, is a specialized fine-tuned built specifically to identify and patch software vulnerabilities. It is deployed exclusively within Google's CodeMender system, where multiple agents work in a swarm to audit large codebases and generate security reports. Most developers will not have access to this tier. It is currently a gated release, limited to governments and specific enterprise partners. This restriction minimizes the risk of the model being used for malicious purposes, so standard security workflows must still rely on the general-purpose 3.6 Flash. All of the public models in this release feature a 1 million token input context window and a 64,000 token maximum output limit. They also support native compute use, allowing the model to autonomously navigate OS-level interfaces and interact with software as an agent would. The addition of native structured outputs means the model can guarantee JSON formatting without the need for additional prompt-based enforcement. These built-in capabilities reduce setup time, but they also bind your agent's core logic more tightly to Google's specific tool calling architecture. The most effective way to use this lineup is through a multi-agent orchestration layer that uses both Flash models in tandem. You assign Gemini 3.6 Flash as the master agent. It handles the high-level strategy, reasoning, and the decision of which tools to invoke. Then you delegate the high-volume work, like text parsing and formatting, to a swarm of 3.5 Flash-Lite subagents. This structure maximizes speed and reduces costs, although it does require you to build more complex error handling logic to manage the interactions between the two tiers. Successfully balancing high-level intelligence with low-latency subagents allows you to scale complex workflows that would otherwise be too expensive to run. This flowchart provides a clear routing rule. Complex reasoning and coding should be sent to Gemini 3.6 Flash. High-volume data extraction tasks route to 3.5 Flash-Lite to preserve the budget. 3.5 Flash Cyber remains reserved for code mender security audits. Looking ahead, Gemini 4 and 3.5 Pro are expected to eventually provide a higher ceiling for zero-shot problem-solving, but you don't need to wait for a single perfect model to begin building. The specialized tools required to run scalable, cost-effective agent swarms are ready to use right now.